Now is we're going to do a difference quotient problem. We're going to do number 67 on page 175, which is section 1.3. Again, when we evaluate the difference quotient, we're going to find the secant line of a function in between a point x and a point with an x. We're going to scoot over a value h, so we get the quantity x plus h. The difference quotient, again, is going to be f of x plus h minus f of x all over h. Okay, so they're going to give us our function in terms of f. They're going to define f of x as, let's see, we've got minus 2x squared plus 5x plus 7. So what I want to do, I need to find what f of x plus h is. They've given me f of x, and then h is simply just going to stay as h. In order to evaluate the quantity f of x plus h, what we do, the rules of our function, this is what my function looks like when I plug x into it. So instead of putting an x here, when I evaluate f of x plus h, I'm just going to plug in the quantity x plus h wherever I see an x. Okay, so let's do that. We're going to go f of x plus h is equal to negative 2 quantity x plus h squared plus 5 quantity x plus h plus 7. Okay? So that's my f of x plus h. Now what I'm going to do is I'm going to take that and evaluate the difference quotient. I know f of x plus h, I know f of x, and I know h. So we're going to evaluate and simplify. Okay? So what I've got here is I've got minus 2 x plus h quantity squared plus 5 quantity x plus h plus 7. That's my difference quotient. Okay? Now I'm going to subtract from that my f of x. Now I'm subtracting a quantity, so it's important to have these parentheses there. Minus 2x squared plus 5x plus 7. Okay? And that's all over h. What I'm going to do here now is just simplify what I've got on top. Okay? Now when you evaluate a difference quotient, when you simplify on top, lots of stuff should cancel, and we're about to see that. Okay, so now I've got minus 2 times the quantity x squared plus 2xh plus h squared, that's what you get when you FOIL that out, okay, plus 5x plus 5h plus 7. This is minus a negative 2x, so I get plus 4x squared minus 5x, I'm distributing the negative now, minus 7, okay, and that's all over h. Now what I'm going to do is just distribute this 2 through and see what I have that cancels. So I get minus 2x squared. That's a 2. Alright, we distribute that through and that becomes a positive 2. I don't know why I got 4. Okay, so then I've got, where am I at? Okay, I got minus 2x squared minus 4xh plus, distributing that negative 2 through, so I've got minus 2h squared plus 5x plus 5h plus 7 plus 2x squared minus 5x minus 7. Now I'm going to see what cancels. I got a minus 2x squared and a plus 2x squared. That's going to cancel. Plus 7 and minus 7 cancel. Minus 5x plus 5x cancel. So I'm left with minus 4xh minus 2h squared and a plus 5h. Okay? And that's all over h. So now I've got minus 2h squared minus 4xh plus 5h. That's all over h. What I'm going to do up top is I'm going to factor out an h, so then I get h times, let's see, minus 2h minus 4x plus 5 all over h. My h's cancel, and I'm left with the solution, which looks like, let's see, minus 2h minus 4x plus 5. Now we should only have a first order x every time we get to the simplification of the difference quotient, because when we evaluate the difference quotient, we're finding the slope of a secant line. Okay, our slope has to be linear because it's a secant line, so you don't want anything over first order x. Okay.